Oh, hi everyone, welcome to the third lesson for week one here for Year 8 Maths. This is Mr. Freiberg again, and today we will be looking at the zero index laws. So again, as I've said during the week, if you have a copy of the teaching notes that you'll also find on the eLearn Classroom, you are welcome to print a copy of those out and follow through this PowerPoint, filling in the blanks as we go. Alternatively, if you have your maths book open in front of you, boys and girls, then your heading for today is the zero index law, and you should be completing this on or before the 23rd of April, so Thursday the 23rd of April. Again, if at any point during this video you can pause it and obviously to write stuff down. For example, on the next slide you'll find our learning intent. If there's anything off that if I go through that too quickly, please pause the video and you'll be able to write it down. The learning intent today is to develop the zero index law on numbers with various bases, and the success criteria is that you'll be expressing division as a fraction, so basically to show you how the actual zero index law works, and the actual zero index law is there on the screen, and that says that any base to the power of 0 equals 1. It looks pretty straightforward. It is pretty straightforward, and of course I'm going to throw in a couple of extra complications in there just to make it a little bit trickier. It's a nice little way to finish this first week off. So by now we should be fairly familiar with what index notation is, and what I'd like you to do in your books, or if you have the notes in front of you, you should find an a to the power of 3. If you're just using your workbook, could you please write down an a to the power of 3 like that, and next to the a draw an arrow, and it's obviously called the base as we've seen, and the 3 is, as we've also seen, called the index. As I explained to you earlier in the week, the index could also be called the power, because I tend to use the word a to the power of 3 rather than a to the index of 3, and you should also know what the base and the power represent by now. If you take a look at those four terms down the bottom, 9 to the power of 6, y to the power of 76, etc., could you please write each one of those out? So if you write down 9 to the power of 6 in your book, underneath, could you please write down what you think the base is and what you think the index is? So for instance, the base on 9 to the power of 6 is 9 and the index is 6. And what I'd like you to do is just to pause the video and maybe spend 30 seconds to a minute now, write out those other three terms and write down what you think is the base and what you think is the index. Well, hopefully you paused the video and you got answers that look like that. You might be able to see that there is actually a little error on mine, because the base of y to the power of 76 is actually y, and the index is 76. Again, check your answers, pause the video if you need. All right, before we start on the zero index law, let's make sure we're all happy and comfortable with what we've done so far this week. Excuse me. Earlier in the week we showed you how to write terms out in terms of factor form, or in other words, this was an expanded form. So if I just go back a slide, sorry about that. So this is expanded form, so in a really big long form. And then we also looked at in question 2 some of those simple index laws for multiplication and division. So what I'd actually like you to do for this slide, boys and girls, is I'd like you to pause the video for about 5 or 10 minutes. I'd like you to write down those 5 questions, and I'd like you to try them in your book. You'll also notice that they are on the notes if you've downloaded the notes, and I'd like you to actually complete those questions on the sheet. Pause the video, as I said, for 5 minutes, and we'll come back and I'll actually work through those solutions. All right, so hopefully you have now completed those 5 questions. You paused the video, and let's now have a look and check some of your answers. So for this first one up here, 4p to the power of 4, if you wrote down 4 times p times p times p times p, you'd be on the right track, because remember I did want it in factor form, and so we'd actually expect you to actually write down the two factors of 4. We could write down 1 and 4 because 1 times 4 equals 4, but we're actually after prime factors, and so the prime factors of 4 are 2 times 2. So your correct answer should actually be 2 times 2 times p times p times p. Why do we write down p 4 times? Because that's what the index is up there. So the second one's a little bit simpler. 2k to the power of 4 m squared, 2 times k times k times k times k, and then we've got m times m because there's 2 of them. Okay. So on Tuesday's live lesson, I actually went through the multiplication and division laws. So for instance, with part A, because the bases are the same and we're multiplying, we're going to add our powers together. So we just keep the base of p and we add our powers together. 9 plus 8. 9 plus 8 equals 17. For the second one, we've got 2y times y to the power of 6. Now again, the bases are the same and we're multiplying, and so we add our powers together. This one's got a little trick in it because there should be a power of 1 there, but we haven't written it in. Now that 2 that sits out the front, we just rewrite it out the front like that. And we're going to add now 1 plus 6. So the answer for that one is 2y to the power of 7. With the third one, now if I just ignore the 12 and the 3 for the time being and look at the m to the power of 6 and m to the power of 4, again you'll notice the bases are the same, and this time we're dividing. And this is when we needed to now subtract the powers. So just off to the side here, I'm going to write m to the power of 6, and I'm going to take away from that 4. So I've got m to the power of 6 minus 4, and if I finish that off now, 6 minus 4 is 2. But now what do I do about the 12 and the 3? Well, I look at that sign in the middle which says divide. So I go 12 divided by 3, and we know 12 divided by 3 equals 4. And so the answer for that one should be 4m to the power of 2. Please make sure you've checked your work and give yourself a tick or a cross if you got it right or wrong. And if you got it wrong, please make sure you fix it up. And if you still need some time to write anything down off this slide, please pause the video now because I'm about to go on. Okay, so today we're looking at the zero index law. So that means we've got all of these terms here. If we look up the top here, all of these terms, they're all raised to the power of 0. Now, what does or what happens when we raise something to the power of 0? So I'm going to simplify each of these. So I can actually simplify this and make the expression smaller. 4 to the power of 0, the answer is 1. If we look at part B, we've got 9 to the power of 0. The answer is 1. We're going to start to sound like a broken record here because 34,565 to the power of 0, you can probably take a guess, and you get it right, the answer is equal to 1. Now, why is this so? Well, let's take a look at this little sum down the bottom here. So down the bottom here, I've got 3 to the power of 2 divided by 3 to the power of 2. Now, if I use the index laws that we've just looked at, the bases are the same, 3 and 3, and I'm dividing. And so you should be able to tell me that I'm going to subtract the powers. So I've got 3 to the power of 2 minus 2, and 2 minus 2 equals 0. But what you might also know is that if you have 3 to the power of 2 divided by 3 to the power of 2, and I write that as a fraction, 3 to the power of 2 over 3 to the power of 2, you might recall from some ideas on fractions that if you have the same on the top and the same on the bottom of a fraction, you could actually rewrite that as 1 whole. So you see that bottom line there? That's actually showing you that 3 to the power of 0 is actually equal to 1 whole. So anything to the power of 0 is equal to 1 whole. And boys and girls, that's our index law for 0. So in your book, what I'd like you to do is write down that the 0 index law is this. Any base raised to the power of 0 always equals 1. And if you have that on your notes, if you've printed the notes out, please make sure you highlight it. And if you're writing this in your book, please make sure you write it nice and clear and prominently, and perhaps put a circle around it. Even as I suggested the other day, you might like to write this in the back of your book as a separate section under index laws. Okay, again, pause the video if you need. So let's take a look at these examples down below here, and if you have needed a little bit of extra time, again, pause the video. But these three examples here, I'd like you to write it in your book. You've got the examples pre-printed on the sheet if you already have that. And these are three pretty simple examples just to show you what the zero index law actually looks like and how it gets used. So the first one, 26 to the power of 0. Well, that's no tricks there. 26 is the base, 0 is the index, and that simplifies down to 1. Now this second one looks a little bit more complicated because it says 12, a to the power of 9, b to the power of 7, c to the power of 2. That's all wrapped up in brackets and it's all raised to the power of 0. Well folks, this thing here, that's our base. So because that is our entire base and that entire base is being raised to the power of 0, the answer is equal to 1. Tricky. How about a real trick? Take a look at this last one. 12b squared c to the power of 0. A lot of people think it looks like the one up above, and so we're just going to write down 1. No. The answer for this last one is not equal to 1. And the reason why is if you look really closely, there's only one part of that last question that's raised to the power of 0, and that's the c. So you can see that it's only this part that's raised to the power of 0. So it's only this part here that equals 1. So what do we do about the rest of it? Well, we still have 12b squared. And what's in between the b squared and the c to the power of 0? It's a multiplication sign. So we've got 12b squared multiplied by 1 because c to the power of 0 equals 1. And so 12b squared times 1 just becomes 12b squared. So that's a bit tricky. So not all of these questions are going to equal 1. You need to be very careful and identify what is the actual base that's being raised to the power of 0. Again, if you need, pause the video so that you can write the answers down. So can we express division as a fraction? Well, I quickly showed you that as to prove this index law. But can you actually work out that any base raised to the power of 0 equals 1? I think you can. But you just need to be very careful to make sure that you identify the correct base that's raised to the power of 0. Well, here's a little bit of practice. So this is the perfect practice that makes perfection. There is actually a very limited section in your textbook. So what I've done is I've taken some of those and I've also added in some of my own. So this slide here is the work that I would like you to complete on the zero index law. As I said, it's a little bit of a nice little way to finish the week off. This is obviously not going to take you the full lesson, so there might be an opportunity as well if you need to complete some of the other set work from earlier in the week that it might be a good opportunity to complete those as well. So as you have seen throughout the rest of the week, once you have completed these questions, make sure you take a scan or a photo and please email it to me or drop it in the assignment drop box that's on the online classroom or on the eLearn classroom on the Learning Place. So in this exercise there's 9 questions and I can give you a little clue and say that not all of the answers will be 1. A couple of them will be, but the rest, well, as I said, you need to identify which is the base that's being raised to the power of 0. Pause the video as you complete those exercises, or if you have the handout, they are on the handout. So the success criteria: can we express division as a fraction? Yes. Can we raise a base to the power of 0 and make that equal to 1? Yes. So that's it for this first week of index laws. We have revised what index laws look like, and looking at your homework from that, or your classwork from that, everyone seems to have got a good understanding of writing terms and writing expressions in terms of index laws and expanding terms. We then looked at the multiplication and division laws and looking at the in the live lesson, I should say, and looking at the completed classwork that people have submitted for those. Again, we've got a pretty good understanding of those. And this is the third of those index laws that we've looked at this week, which was the zero index law. And if you complete those exercises and get them to me, that would be fantastic. Next week, folks, we look at the last index law, which is the power of a power. It's basically the multiplication index law. And there are a couple of extra little complications when it comes to that one. And I think in the live lesson, we're going to look at the slightly harder version of that. So Monday's lesson will be an introduction to the power of a power law. Tuesday, we'll look at all of the complications. And then Thursday's, I guess, time slot for you will be a little bit of a consolidation around that. Anyway, as always, make sure that you check out the online classroom so that you'll be able to keep up to date with all of that classwork. Watch out for some emails and announcements when I've added the classwork to the online classroom. And thank you very much for all of your hard work this week. And I look forward to speaking with you and to you next week. Have a great weekend, everyone, and see you then. Bye.